Welcome to this lecture. In this lecture, we will learn to use EfficientNet models inside our Flutter application, and we are gonna perform image classification using them. So the first step is downloading the model from TensorFlow Hub. So you need to open the site and you should move to this page, or you can simply directly type this URL here. And we have learned that how we can get the models which are compatible with our ML Kit library earlier. So here once this page is opened, scroll down, and this time we are gonna use an EfficientNet model. So there you can see this EfficientNet Lite 4 model. So let's click on it and the details will be opened. And in the details you can see the model size is 14 MB, and we got multiple versions of this model. Like here we got this quantized model, but we also got the floating version of this model as well. And the size of this floating model is 50 MB. But we will gonna download this quantized model. So just click again here and download this model. And there you can see the model downloaded started. So now let's wait for our model downloading to be completed. So now our model is downloaded and we got this model here. And the next step is adding this model inside our Flutter application and performing image classification. And to do that, you need to open the application code that we completed earlier. So for now, I have opened this application where we have integrated our MobileNet model earlier. So in order to use our EfficientNet model, just copy this model file and we need to paste this model inside our ML folder. Now click OK and the model will be added. Similarly, you can double click on this model and read the details. And by doing that, you can also confirm that this model is containing the metadata along with the model file. And that is the requirement to use this TF-Lite model with our MLKit library. So after pasting the model here, we need to change one thing inside our application, and that is this model file name here. Apart from that, we don't need to change anything. So as our model name is quite complex, so let's firstly rename it. So right click and click refactor, rename. And we are gonna simply name this model EfficientNet. After doing that, let's copy it as well and click on this refactor. And now here we need to specify the name, so I'm gonna paste it here and that's it. So now we can simply run this application inside the simulator again, and this time this EfficientNet model will be used instead of this MobileNet. So that is how easy it is to use some other image classification model inside this application. So let's install the application again and test it. So now the application is installed again, and here let's test it by choosing an image from gallery. But before that, I also got the label file for this EfficientNet model, and we previously have learned that how we can get this label file from our model file. And there you can see in this file we got around 1000 objects which our model can recognize. Like we got this hen, ostrich and so on. So let's test this model. So I'm gonna choose this hen image from gallery. And there you can see we got this label hen and the confidence score is 86%. So our application is working correctly. And in case of this EfficientNet model, you may see that the results are being returned after some time. And the reason is this is the EfficientNet Lite 4 model, which is the heavier as compared to EfficientNet Lite 3, 2, 1 and 0. So those are the lighter versions of EfficientNet models and you can use them as well. Similarly, let's choose another image, like we are gonna choose these bananas. And there you can see we got the prediction banana with the confidence score of 89%. So our application is working correctly and we are getting the predictions returned by this EfficientNet model. So now I have installed the application again, and this time we are using the EfficientNet model for image classification. And you can see the results are much more better, as we are getting above 95% accuracy for this microphone. Similarly for this trailer truck, you can see the results are also quite good. So let's try it for this lampshade or lamp. And there you can see we are getting this prediction here. And finally, for our keyboard, you can see it is also detecting it with the confidence score above 80%. So this EfficientNet model is working quite well as compared to our MobileNet model in our scenario. But in your case, you can test both of these models and then let us know that what you think is working best in case of image classification. Hello and welcome to Pre-trained Models for Object Detection section of this course. As we have used the object detection model of our ML Kit library in Flutter with both images and the live camera footage. So the default object detection model can detect different objects present in frame or images, but it uses an image classification model to recognize those detected objects. And to understand the process, let's take an example. So suppose we got this dog image and we pass it to our object detection model of MLKit library. Then the object detection model will going to recognize the dog present in the image, but it cannot recognize that dog by itself. So after recognizing the dog, the library crops the image and passes the part where the dog is present to an image classification model. Then that image classification model will going to recognize that the detected object is a dog. And after that the library will combine both of these things and we will get this result where we got a rectangle around this dog and also the label dog assigned to it. So collectively there are two things. Firstly, an object detection model to locate the object, and secondly, an image classification model to recognize the detected object. And now in this section, we are going to use this object detection model of MLKit library, but in order to recognize the detected objects, we are going to use some pre-trained image classification models. So hopefully you got the idea that what we are going to do in this section. So we will combine object detection model of MLKit library with some pre-trained image classification models. And the object detection model will going to detect or locate the objects, and the image classification model will going to recognize that object. And we are going to use some popular pre-trained image classification models to recognize those objects. So in this section we will explore more than 100 image classification models and use two of them in Flutter with both images and the live camera footage. And those models are MobileNet model and EfficientNet model. So we will learn to download existing model in TF-Lite format. After that we will analyze them and extract the information like input, output and the names of classes which these models can recognize. And then finally we will use them in Flutter with Object Detection API to detect and recognize the objects with images and the live camera footage. So as the section involves performing object detection using some existing object detection model, so let's begin. Hello and welcome to this lecture. In this lecture, we are going to build our Flutter application where we are gonna perform object detection using the ML Kit plus a custom image classifier. So we are going to use the MobileNet model inside our object detection application to recognize the detected objects. As previously, we have completed the object detection section of this course, where we have used the ML Kit library to perform object detection with both images and the live camera footage. So in those applications, we are detecting objects and recognizing them using the default model of our ML Kit library. But now we are gonna use the object detection feature of ML Kit library to detect or locate the objects. But in order to recognize them, we are gonna use our custom model. So let's begin. So firstly, we are gonna use our custom classifier with images inside Flutter. And later we are gonna use the live camera footage with it. So in order to build that application, we are gonna take our object detection application code that we completed earlier, where we learned to integrate object detection in Flutter with images. So that is the complete application code, and if you have completed that application, then you can open that application code. Otherwise you can take it from GitHub. So open your browser and type this URL here. Once the repository page is opened, just click on the code button and copy this link. Now open Android Studio and click on this Get From Version Control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the application code is imported. So let's firstly run this application inside an emulator and verify that this application is working or not. So in this application, we are performing object detection in Flutter with images, and we are using the default model of our ML Kit library. So let's run this application and verify its functionality. So I am going to install this application inside an emulator. So now the application is installed inside the simulator, and that's the GUI of this application. So in this application, user can choose an image from gallery by clicking on this icon, and he can open the camera by long pressing on it. So let's choose an image. So we are going to choose this apple image for now. And there you can see a rectangle is being drawn around this apple, and we also got the category name. So our model thinks that this apple is belonging to a food category, which is right. So in this application, in order to detect this apple, the object detection model is being used. But in order to recognize it, the custom classifier of our ML Kit library is being used. And now we are gonna use our own custom classifier inside this application to recognize the detected objects. So firstly, we are gonna use the MobileNet model, and later we are going to train our own custom model, and we are gonna use it inside this object detection application. But for now, you can see our application is working. And now let's quickly look at this application code. So I'm gonna open our pubspec.yaml file, and here you can see in the dependencies, we got this dependency to choose images from gallery or capture them using camera. So that is this library image picker. Similarly, we got this MLKit object detection library, and by using it, we are performing object detection. And inside our lib folder, open this main dot dot, and there we got this application related code. So firstly, we are displaying the UI inside our build method. So there we are displaying this image inside this elevated button, and when the user will gonna press on it, this image from gallery will be called, and when he will gonna long press on it, this image from camera will be called. And inside these methods, we are choosing or capturing the images. So you can see this code here. And once user will gonna choose or capture the image, we are calling this do object detection method. And inside this method, we are using our object detector, and we are passing our input image to it, and it will gonna return us the detected objects. After that, we are drawing the rectangles on screen with the help of our object painter class. So there you can see this class, and inside it we are drawing the rectangles around detected objects using this canvas.drawRect function. And we have covered all of this code when we built our object detection application. So if you have any confusion related to it, you must complete that section and then proceed to that one. Otherwise, you will find it difficult. And now the next step is using our custom classifier inside this object detection application and using it to recognize detected objects. And we are gonna do that inside our upcoming lectures. So see you in the next lecture. Hello and welcome to this lecture. In this lecture, we will learn to download pre-trained machine learning models in a TF-Lite format, as we want to perform object detection using the custom TensorFlow Lite models. So firstly, we need to find those models, and then we are gonna use them. And if you have completed the section where we integrated custom TensorFlow Lite models in Flutter, then you already know the process that where you can find such models. Otherwise, you can follow me on this lecture. So in order to find such models, you need to open your browser and search for a site called TensorFlow Hub. So I'm gonna type it here and press enter. And there you can see this site TensorFlow Hub. So just click on it, and the home page for this site will be opened. So this TensorFlow Hub is a repository for trained machine learning models, which we can just download and use it inside our applications. So there you can see this models tab, so just click on it. And now on this page you can search for different models or filter them with the help of these selections. So as we want to download the models which are compatible with our ML Kit library, and we want to use those models to recognize detected objects. So basically we need image classification models, but those models must be compatible with our ML Kit library. So here we can search using a term metadata. And the reason is we only use the models with our ML Kit library which have a metadata associated with them. Otherwise, we will not be able to use the model with our ML Kit library. So that's why we are searching with the help of this term. And in the search result, you can see this collection image classification, and the publisher is ML Kit. And there are 112 models which we can use inside our Flutter application after downloading it from this collection. So just click on this image collection and you will see the list of models. So now here scroll down and click on this see all button. And now you can see all the models which you can just download and use it inside your Flutter application with the help of ML Kit library. So there you can see we got this MobileNet model, this EfficientNet model. Similarly, we got this model to recognize different landmarks of North America, and we got some other models as well. So you can read the detail of each model, and then based upon your use case, you can download the model and use it inside your application. Like here, we are gonna download a MobileNet model and we are gonna use it inside our application. So scroll down and there you will see this MobileNet V1 model. So just click on it and here you will find the further details of this model. Like you are gonna find the size of this model along with the different versions of this model. So you can see we got two tabs here. Firstly, this TF Lite model with the default category. So that is the default MobileNet model, but the model does not contain a metadata with it. And secondly, we got this TF Lite model which have a metadata associated with it. So as we want to use that model, so we are just going to download it by clicking on this download button. And there you can see our model downloading started. So now let's wait for our model to be downloaded. So now the downloading of our model is completed, so let's open the location. And after that, let's copy this model file. And we need to paste this file inside our Android Studio project. So this is the Android Studio project we imported earlier. And now inside it, we are gonna add that model. And to add them, we are gonna create a new directory and we are gonna name it assets. So let's create it and name assets. And inside this assets directory, let's create a new directory and name it ML. And this ML is for machine learning. And now inside this folder, we are gonna paste our model. And before pasting it, let's rename it to MobileNet. And now click OK and the model will be added. And when you are gonna click on this MobileNet.tf Lite, you can see this detail. And the reason is this TF Lite model is containing the metadata along with the model file itself. So we can see the details of this model. Like here we can see the input. So this model will gonna take an input image of size 224 by 224. Similarly, we can see the output. So the output is an array of size 1001. So it means that this model can recognize up to 1001 different items. And we are able to see this detail because the model contains this information in the form of metadata. Similarly, the model also contains the name of all 1001 objects which it can recognize. And we can extract those names, and we are gonna do that inside our upcoming lecture. But for now, we have just downloaded the model and added it inside our Android Studio project. And after that, we need to declare this ML folder inside our pubspec.yaml file so that we can use this model inside our application. So here inside our pubspec.yaml file, below this images, let's declare our assets folder. So assets /ml/ and that's it. Now we can use the model which is present inside this ML folder inside our application. And we are gonna do that inside our next lecture. So see you in the next lecture. Welcome to this lecture. As previously we have downloaded this MobileNet model and we added it inside our Flutter application. And now it's time to load this model and use it along with our object detection feature of ML Kit library. And as you can see in this application, we are performing object detection using the object detection feature and default image classifier. And we have declared our object detector here and we are initializing it here. But this time we also need to load this MobileNet model and use it along with this object detector. And to do that, we need to open the documentation page for this Google ML Kit object detection library. So I have already opened it, and you can just open it by going to this site pub.dev, and there you can search for this Google ML Kit object detection. So there we have the instructions that we followed to build our application. And now we want to use our custom model. So here when you are gonna scroll down, you can see this section load local custom model. So there you will find the instructions to load that TF-Lite model. And the first step is adding the model inside our project and declaring the folder inside our pubspec.yml file. And we have already done that. After that, we need to paste this method inside our application code. So we need to copy this getModel function and then we are gonna paste it inside our main dot dot. So just copy this model without the imports and paste it inside this main dot dot file just above this do object detection method. So I'm gonna paste it here. And there you are gonna see a couple of errors. Like you can see this error for get application support directory and for other things. So in order to remove them, we need to add the imports. So open the documentation page again and let's copy these imports. And we are gonna paste them at the top of our main dot dot file. So I'm gonna paste it here. And now when you are gonna scroll down, you will see that majority of the errors are gone. And in order to remove these errors because of this IO library, let's remove this IO dot from here. So remove it from here as well. And now there is only one error, and that is because of this get application support directory. And this is the method present inside our path provider package, and it is an external package and we did not edit it inside our pubspec.yml file. So now we need to add this package inside our project and then this error will be gone. And we are using this package to get the exact path of our model file, and then we are gonna use that path to load this model. So open your browser and go to this pub.dev again, and there we are gonna search for this package. So here on this site, search for path provider, and there you can see this first result with 100% popularity. So just click on it. And now in the installing section, you will find the dependency. So just copy this line and paste it inside our pubspec.yml file. So we are gonna paste it here just below this Google ML Kit object detection. So I'm gonna paste it here. Now click pub.get so that this library will be downloaded and added inside our Flutter project. So there you can see in 3.5 seconds the package is downloaded. And when you are gonna open main dot dot, you can see now the errors are gone. So here you can see we pasted this getModel function, and in this function we are passing the path of this MobileNet.TF-Lite, and this model will gonna return the true path which can be used by our object detection library to load the model. So in order to use this method and load our model, open the documentation page for the library again. So on this Google ML Kit object detection library page, when you are gonna scroll down, you can see this section, create an instance of image labeler. So there you can see we are creating our object detector here, and inside it we are passing these options. But now we are not passing the regular options, but we are creating a variable of type local object detector options, and there we can specify the path of our model file as well. So along with the object detection model of ML Kit library, this time our custom labeler or our MobileNet model will also be loaded. So just copy this code and we are gonna paste this code inside our main.dot file by creating a new method. So here let's create a new method and name it create object detector. And inside this method we are gonna paste the code. And now let's look at it. So there you can see inside this method, firstly we are calling this get model function and we are specifying the path of our tf-lite file. As in our case, our model is named as MobileNet, so I'm gonna pass MobileNet here. Similarly, you can see the error because of this await keyword, so we need to make this method asynchronous. So just click on this add asynchronous modifier and the error will be gone. So now when this line will be executed, we will get the true path and then we are passing it to our model path property. And then we are passing this model path inside our local object detector options. So here we are specifying it, and after that we are passing this classify objects to true because we also want to recognize the detected objects, but this time using this model, this MobileNet.tf-lite. Similarly, we are also passing multiple objects to true, which means that multiple objects will be detected. Similarly, you can see the error here on this local object detector. And the reason is we also need to specify the mode parameter. So by using this mode parameter, we can choose that if we want to perform object detection with a single image or with the live camera footage. So based upon our choice, the model will gonna behave. And here we are gonna specify the mode using this detection mode dot, and you can see this option single or stream. As in this application we are performing object detection with images, so we are gonna choose single mode here. And if you are performing it with the live camera footage, then you can choose the mode to stream. So now you can see the error is gone. So after creating our option and specifying the path of our model file, we are creating our object detector and passing this option, and we are assigning it to this object detector variable. So above we have already declared this object detector here, and we are initializing it inside our init state method. So there we are using the default classifier along with the object detector. So now let's remove the code because this time we want to load our custom model. And here we are gonna call our method create object detector, and inside this method we just wrote the code. And when you are gonna scroll down, there you can see in this method we have pasted all of this code. Similarly, let's remove this final from here because we have declared it above. So now when this method will be called, our object detector will be created and initialized along with this MobileNet model. So now this object detector will gonna detect the objects, but it will gonna recognize them using this MobileNet classifier. So we are performing object detector with the help of object detection model of our ML Kit library, but then we are recognizing those detected objects with the help of our image classification model. And by using that approach, we don't need to train our object detection model. We can just train an image classification model and use it with the object detection model of our ML Kit library. So hopefully you got the idea. So now here in this application, when this init state method will be called, this create object detection method will be called inside it, and our object detection model will be loaded. And then we are using this object detector inside this do object detection method to detect and recognize the objects. So we don't need to change anything inside this application code, and you can simply run this application and test it. And the reason is we have just changed the loading procedure for our object detection model. Previously we were loading the default object detection model along with the default classifier, but now we are loading that default object detection model with our custom image classification model. So we don't need to change anything, as earlier that model was being used using this object detection variable. Now our own custom image classifier is being used using this variable. So now let's run this application inside the simulator again and test it. So click on the stop button and install the application again inside the simulator. So now the application is installed again, so let's choose the image from gallery again. So we are gonna choose the image of object which our model can recognize. Like it can recognize ostrich, so let's choose this image. And there you can see our model is detecting that ostrich and it is assigning the label ostrich to it, which is 100% correct. So our application is working correctly, and in this prediction we got this location of ostrich using the object detection model of our ML Kit library. But we got this label ostrich because of our MobileNet model. So we are combining them to build a powerful object detection application. Similarly, let's choose another image like this microphone. And there you can see we got the label microphone here. And again, the object detection is being performed using ML Kit, and this label is being assigned because of our image classification model. So now let's quickly review the process that how we have built this application. So firstly we got our application code from GitHub, and in that application we are performing object detection with images in Flutter, and we are using the default object detection model and image classifier to detect and recognize the objects. And we have completed this application inside our object detection section of this course. But now we want to use this MobileNet model to recognize detected objects. So for that purpose, we created this assets folder, and inside it this ML folder. And inside that folder, we pasted our MobileNet.tf lite file, and we have downloaded it from TensorFlow hub. After that, inside our pubspec.yaml file, we declared this ML folder, and inside this file we also added these dependencies. So this image picker and Google ML Kit object detection was already there, and we added this path provider to load this model. And inside our main.dart file, in order to load this tf-lite file, we pasted two methods. Firstly, we pasted this getModel function, and this function will gonna return us the true path of this MobileNet model. After that, we created this function createObjectDetector, and here by using this method, we are getting the correct path of our model file and creating our object detector. So to this object detector, we are passing this local object detector options, and here we are specifying the path of our model file. So when this method call will be executed, our custom image classifier or this MobileNet model will be loaded along with the object detection model. And then we are using it to detect and recognize the objects inside this application. So that's how we are using this TF-Lite model inside this application to recognize detected objects. And I am repeating this thing over and over again because it's very important to understand that the objects are being detected with the help of object detection model of our ML Kit library, and then we are passing these detected objects to our image classification models, and it is recognizing them. Hello and welcome to this lecture. As previously we have completed our object detection application where we were using MobileNet model as classifier. So we were basically detecting objects using the object detection feature of ML Kit library, and then we are recognizing them with the help of our MobileNet model. And now we are gonna do the same for our real-time object detection application. So in this application, we are gonna detect the objects using the object detection model of our ML Kit library. And then we are gonna recognize those objects with the help of our MobileNet model. And we are gonna do both of these things in real time. So let's begin. So the first step is getting our application code, and we are using the same application that we built inside our object detection section where we integrated object detection feature of ML Kit library with the live camera footage. So if you have completed that section, then you can open that application code. Otherwise, you can take this completed application code from GitHub. So open your browser and type this URL. And once this repository page is opened, just click on the code button and copy this repository link. Then open your Android Studio and click on this Get From Version Control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the application code is cloned, and let's firstly install this application inside an emulator and see whether the live camera footage is being displayed or not. Similarly, you can install this application inside your real device and test the working of this application. So in this application, we are detecting the objects in real time with the help of default model of our ML Kit library. And now we are gonna customize it to use MobileNet model inside it. So let's firstly run this application inside an emulator. So now our application is installed inside this emulator, and you can see the camera preview for this emulator here. And when you are going to run this application inside your real device, you will see the live camera footage will be displayed inside this application, and it is also gonna detect the objects present in the frame. As for now, we are running it inside the emulator, so it is not doing that. And now inside this application, we are gonna use our MobileNet model to recognize the detected objects. And we are gonna do that inside our next lecture. But for now, let's quickly look at this application code. So firstly, we got this pubspec.yaml file, and inside it, we are using these libraries. So we are using this Google ML Kit object detection to perform object detection. And then we are using this camera package to display this live camera footage. And when you are gonna open this main dot, here we got this application code. So there you can see inside our initialize camera, we are initializing our object detector. Similarly, we are initializing this camera controller, and with the help of this controller, we are able to display the live camera footage. And once the live camera footage will gonna start displaying, we are getting each frame of the live camera footage with the help of this start image stream. So there we are getting each frame and calling this do object detection on frame method. And inside this method, we are converting this frame into our input image format and passing it to our object detector. So there you can see we are passing it to our process image of this object detector, and it will gonna return us the results or objects for this frame. And then we are assigning it to this scan result variable, and we are passing this scan result variable here inside our GUI to our custom painter class. So there you can see we got this build method, and inside it we are creating an object of type object detector painter. So we are passing our detected object to this painter, and this painter is being displayed inside this custom paint widget. So when you are gonna scroll down, you can see this object detector painter. So inside it we are iterating this list of objects and drawing the rectangle for each detected object. And we are also drawing the name of the detected objects on the canvas as well. And we have built this application inside our object detection section, so if you did not complete that section, then you must do it. Otherwise, you may find it difficult to understand this application code. And now inside our next lecture, we are going to make changes in this application code, and we are gonna use our MobileNet model to recognize detected objects. So see you in the next lecture. And now it's time to use our MobileNet model inside this object detection application, and we are gonna recognize the detected objects using that MobileNet classification model. So we already downloaded this model when we have used it inside our object detection images application earlier. So make sure that you have took the other lectures of this section before proceeding to this one. So we got this MobileNet model, and the next step is adding it inside this Flutter project. And if you have built the previous application where we have integrated this model with images, then you can do it by yourself. Otherwise, follow me on this lecture. So just copy this model file, and on our Android Studio project, right click on the project name. So go to new and create a directory, and we are gonna name it assets. And inside this assets directory, let's create a new directory and name it ML. So the ML stands for machine learning. And now inside it, we are gonna paste the model. And before pasting it, let's rename it to just MobileNet. Now click OK and click on this add button. So now you can see our mobilenet.tflite file here, and when you are gonna click on it, you can see the detail. And the reason is this MobileNet model is containing the metadata along with the model file. So we can read the instructions like the input and the output of the model. So here you can see in the input section, our model will gonna take an input image of size 224 by 224. Similarly, the output will be an array of size 1001, which means that our model can recognize up to 1001 different objects. And after looking at the detail for this model, the next thing is declaring this ML folder inside our pubspec.yaml file so that the model present inside it can be accessed by our application. So inside this pubspec.yaml file, we need to add this folder. So there you can see this assets section. So just select it and uncomment it. After that, we need to correct these spacing and they should match with this uses material design. So be very careful for these permissions. So I'm gonna remove one space from here, and after that let's remove this second line as well. And now here we are gonna declare our assets folder. So type assets /ml/ and that's it. So now we have declared this ML folder and the model present inside it can be used by our application. And after doing that, the next step is loading this MobileNet model inside our main dot dot. As for now, you can see we are using the default object detection and image labeler model. But now we need to use this MobileNet as your custom image labeler. So inside our init state, you can see we got our object detector. So we are calling this initialize camera method here, and inside it we are initializing our object detector. But here we are using this custom object detector options and we are not specifying our labeler. And this time we need to specify this MobileNet as our custom image labeling model for this object detection library. And in order to do that, we need to open the documentation page for our Google ML Kit object detection library. And I already got it here. And you can simply open it by going to this pub.dev, and there you can search for this Google ML Kit object detection. And once this page is opened, you can scroll down and see the instructions. And these are the instructions we followed when we built this application inside our previous section. And now we need to look at the instructions mentioned here. So you can see this load local custom model. And for that purpose, the first instruction is adding the TF-Lite model and declaring it inside our pubspec.yaml file. And we have already done that. And the next instruction is adding this get model function. And this function will gonna take the path of our model file and it will gonna return the true path, which can be used by our object detector to load the model. So for now, let's copy this function without the imports. And we need to paste this function inside our application code and paste it above this do object detection on frame method. So I'm gonna paste it here, and now you will see the errors. And to remove them, just copy the imports and we are gonna paste them at the top of our main dot dot. So here paste these imports and you will see this error for path provider library. And the reason is it is an external library and we did not added it inside our pubspec.yaml file. And we are gonna do that in a moment. But for now, scroll down and here remove this IO dot. So let's remove it from here, here, and here. And now you can see there is only one error, and that is because of this get application support directory, and it is a method of our path provider library. So in this method, we are gonna take the path of this TF-Lite model and it will gonna return the exact path which can be used by our object detection model. And here in order to get that, we are using this method of our path provider library. So the next step is adding this path provider library inside our pubspec.yaml file. So here we need to add the dependency. And to do that, open your browser and go to the site pub.dev. And there you can search for this path provider library. And once the documentation page for that library will be opened, go to the installing section, and here you need to copy this dependency. So just copy it, and we are gonna paste it inside our dependency section. And here let's add the spacing and click on this pub get, and you will see the library will be downloaded and it will be added inside our project. And there you can see the library is downloaded, and inside our main the error is gone. So after pasting this method, the next thing is calling this method and loading our MobileNet model. And to do that, open the documentation page again, and here you can see the next instruction is creating an instance of our object detector. So we need to copy this code and then we are gonna look at it. So just copy this code and we are gonna paste it inside our initialize camera method. So there you can see earlier we are creating and initializing our object detector here, but this time we are gonna remove this previous code and we are gonna paste this new code here. And there you can see in this new code we are calling this get model function that we pasted below, so this one, and passing our model file path, so this tflite model. As in our case, our model file name is mobilenet.tflite, so just change it here. So mobilenet.tflite. And after calling this function, we will get the real path, and then we are creating an object of type local object detector options. As earlier, we were just creating our object detection option variable, but now we want to load the custom image classification model, so we are creating this one. And here we are going to pass the path of our image classification model that we want to use with this object detection model. So we are passing this path here, then setting the classify objects to true because we want to classify the detected objects. Similarly, we are passing this multiple objects to true as well. And here you can see this error, and that is because we also need to set the mode property. So let's set the mode here, and we are gonna choose this mode to stream. So using this detection mode.stream, we can get the mode. As we are building a real-time application, so our mode will be stream. Otherwise, we can choose the mode to single if we are using it with images. So pass this mode here. And that's it. So now you can see the error is gone. So after creating this option, we are passing it to our object detector, and our object detector will be initialized. And we have declared this object detector above, so let's remove this final from here. And that's it. So these are the changes we need to make inside this application to use our custom image classifier, and we don't need to change anything inside this application. So you can simply run this application inside your real device and you can test the working of this application. And this time you will see that this MobileNet model will be used to recognize the detected objects. So what we have changed in this application, we just pasted our custom image classification model inside this assets ML folder and declared this ML folder inside our pubspec.yaml file. And after that we pasted this method, and then we are calling this method here to get the exact path of our model. And then we are creating our object detector. So earlier where we are creating the default object detector, there we have replaced the code and we are creating the object detector with this MobileNet model as a classifier. And we are not changing anything else. And this object detector will be used to detect the objects present in the frames of the live camera footage. And in order to recognize those detected objects, this MobileNet model will be used. So we are not changing anything else in this application code. So now let's run this application inside our real device and test it. So now I have installed the application again inside my real device, and we are using the MobileNet model here. And there you can see when I am pointing the camera at this laptop picture, this laptop is being detected quite well. And as we have enabled the multiple detections, so the model is also trying to detect other objects present in the frame, but it is not able to do that as our image classification model is not detecting them. Similarly, when I am pointing it at my microphone, you can see it is also being detected quite well. And finally, let's try it for the lamp that I got. So there you can see it is also being detected as table lamp. So collectively, our application is working quite well and we are getting the results in real time. Welcome to this lecture. In this lecture, we are going to download another image classification model and we are gonna use it with object detection feature of ML Kit to detect and recognize several objects. So I have opened TensorFlow Hub again and here I have opened the collection where we got the image classification models which are compatible with our ML Kit library. So here we need to choose another model. So it's up to you that which model you want to use. Like here you can see this landmark classifier which is for the region North America. Similarly you will find this landmark classifier for different regions. And we also got some birds classifier, insects classifier and mushroom classifiers. Apart from that we also got the family of EfficientNet models as well. So it's up to us that which model we want to use. So I'm gonna go with this EfficientNet Lite 4 model. So let's click on it. And there you can see the details of this model. So the model size is approximately 15 MB. And we got 3 different versions of this model. So there you can see these 4 tabs and here this floating point 32 is the floating point model. And you can see the model size is almost 50 MB. Similarly, this integer 8 is the quantized version and we also got this uint 8 and it is also quantized. And we are gonna use this integer 8 model and its size is 15 MB. So let's simply download it and after that we are gonna add it inside our Flutter application and perform object detection with both images and the live camera footage using this model. So there you can see our model downloading started. Welcome to this lecture. In this lecture, we are going to use this EfficientNet model with the live camera footage inside Flutter and perform object detection. So as we downloaded this model, so now it's time to use it inside Flutter. So just copy this model file and open your application code. And this is the application code in which we are using the MobileNet model to recognize detected objects. And we completed it earlier. So make sure that you will complete that section, otherwise you will not learn that how we can download and use custom image classifier to perform object detection in Flutter. So after opening this project code, just paste the model file inside this ML folder and let's rename it to EfficientNet. Now click OK and the model will be added. So there you can see this EfficientNet and when you are gonna click on it, you can see the detail of this model and the reason is the model also contains the metadata along with the model file. So you can see the model will gonna take an input image of size 300 by 300 an input and the output will be an array of size 1000. So this model can recognize up to 1000 different items. So after adding the model, the next thing is using this model to recognize detected objects. So inside our main dot, when you are gonna scroll down, you can see here we are specifying the model name. So as previously we are using the MobileNet model and now we want to use this EfficientNet model. So in order to use it, we just need to change the model name here and that's it. So be careful with the spellings because if you put it wrong, then your model file will not be loaded and you will get an error that model not found. So after specifying the name of model, we can simply run this application inside our real device again and test it. Similarly, if you want to use some other image classification model to recognize detected objects, you can simply download that model from TensorFlow Hub and put it inside this ML folder. After that, you need to specify the model name here, and that's it. So now let's run the application inside our real device and test the working of this EfficientNet model. So I am going to install this application. So now I have installed the application inside my real device, and in this application we are using the EfficientNet model. So there I am pointing the camera at Peacock and it is being detected quite well along with the location. Similarly, it is detecting few other objects, but our image classification model is not able to classify them. And now let's try it for some different birds, like for these bulbuls. So there you can see when I am pointing the camera, it is detecting multiple objects of bulbul present in the frame. Similarly, let's move the camera a little bit around and check the results. So there you can see when we are moving the camera, it is trying to maintain the prediction as it is also tracking the detected objects. So our application is working correctly and we are able to detect and track objects using the EfficientNet model. Hello and welcome to Training Machine Learning Model section of this course. Apart from using the pre-trained models, one might want to train his own machine learning model for his particular use case. For example, apart from using the 1000 classes of MobileNet model, we want to build a Flutter application to recognize different types of fruits or detect some specific objects. And to achieve that, in this section, we will learn to train image classification models without knowing any background knowledge of machine learning. After that, we will use these models inside Flutter to perform both image classification and object detection. So, to train our image classification model, we will follow an approach called transfer learning. In transfer learning, we will take existing machine learning models and retrain them on our custom datasets. And in our case, we will retrain 3 popular families of machine learning models on our custom datasets. And those families are MobileNet models, EfficientNet models, and the ResNet model family. So we are going to take the models of these families and retrain them on our custom datasets. And by doing that, we are able to utilize the power of those models to recognize the things present inside our dataset. And in this section, we will train a machine learning model to recognize several fruits. So we will learn to collect dataset for training models, train machine learning models on those datasets, and after training, we are going to test those models. And finally, we are going to convert them into a TF-Lite format to use them inside our mobile applications. So after completing this section, you will be able to collect and organize your dataset for training image classification models. And you will be able to use them in Flutter to perform both image classification and object detection. So let's begin. Hello and welcome to this lecture. In this lecture, we will start the process of training our image classification model, and later we are gonna use that model inside Flutter to perform both image classification and object detection. So we are going to train an image classification model to recognize several fruits. And when we talk about training a model, the first thing we need is the dataset. And as we are training an image classification model, so our dataset will gonna consist of images. So how we can get the dataset for training our model? So for getting the dataset, there are a couple of approaches. And the first one is collecting the images by ourselves. So for example, if we want to train a model to recognize apple and banana, then we can go to internet and search for those pictures and download them one by one. And the other approach is using some existing dataset. And that is the approach we are gonna use. So here in this lecture, we will see that how we can get the existing datasets for training our image classification model. So open your browser and go to Google. And there you need to search for Kaggle. So type it and press enter. And here you can see this first link, so just click on it, and that is for the site kaggle.com. And now the home page for Kaggle is opened. So Kaggle is the world's largest data science community where you can find free resources related to data science and machine learning. And in our case, we want to find a dataset. So just in the search bar, type the details of the dataset you want. As we want a fruits dataset, so I'm gonna type fruits here. After that, press enter, and now you can see the results. So there you can see this dataset tab, so just click on it and you will find 235 different datasets related to fruits, and you can read the details for all of them by visiting the page of each dataset. Like here you can see this fruits and vegetable image recognition dataset. So just click on it and the details for this dataset will be opened. And now here you can see further details for this dataset. So you can read this dataset contains 3 folders: train, test and validation. And in training folder there are 100 images for each fruit and vegetable. And in test folder there are 10 images for each fruit and vegetable. Similarly, there are 10 validation images for each of the item present in the dataset. Similarly, you can read about the classes, like it contain banana, apple, pear, grapes, orange, kiwi, watermelon, pomegranate, pineapple, mango, and for vegetables it contain all of these vegetable images. So after looking at the details, you can select a dataset that you are gonna use to train the model. So this dataset seems perfect for our use case, so we can just download it. And to download it, we firstly need to sign in or register on this site kaggle.com. So if you got your Google account, then you can simply sign in with the help of that account. Like here I'm gonna click on this sign in with Google. And now you can see my Google account is attached. And after that, when I am going to click on this download button, our dataset download will gonna start. So there you can see the download is just started. So now let's wait for this dataset to be downloaded, and then we are gonna explore it further. So now the downloading of our dataset is completed and we got this archive.zip file. So the first step is unzipping it. So I'm gonna extract it. So now the extraction of this file is completed and we got this archive folder. And inside it you can see these 3 folders: this train folder, this test folder and this validation folder. So let's open this train folder, and inside it you will find these different folders. Like we got this apple, banana and some other folders. And in this apple folder you will find all the images of apple. It contains pictures of apple in different scenarios. Similarly, when you are gonna open some other folder like this pineapple, you can see all pineapple images here, and same is the case for the remaining folders. So as you can see, this dataset is containing more than 25 objects. And now it's time to train our machine learning model on this dataset. But in order to train the model, we will not use all of these fruits or vegetables. We will just select 4 different fruits and train our image classification model on it. And if you want to train the model on all of these fruits and vegetables, then you can also do it. But we are going to stick with the 4 different fruits. So we are going to choose this apple, this pineapple, and after that we are going to choose this watermelon. Similarly, we are going to choose this kiwi. So we are going to train an image classification model to recognize these 4 fruits. So after selecting them, just copy them and paste them inside a separate folder. So here I'm going to create a new folder and let's name it dataset. And inside this folder, I'm gonna paste these 4 folders. And now you can see all of these 4 folders here. So now we have downloaded our dataset from Kaggle and we selected few classes on which we are going to train our image classification model. And the next step is uploading this dataset on Google Drive so that later we can use it to train our image classification model. and we are going to do that inside our next lecture. So see you in the next lecture. Welcome to this lecture. As previously we have downloaded our dataset and we uploaded it on Google Drive. And now it's time to use this dataset and train our image classification model. And to do that, we are gonna start the process in this lecture. So we will begin by opening our browser and going to this google.com. And here you need to search for image classification model maker and press enter. And now in the search results, you will see this link, image classification with TensorFlow Lite model maker. So just click on it. And now this page will be opened. So here you will find a Python notebook which will gonna contain the code to train an image classification model on our custom dataset. And this notebook is provided by Google. So this is the most efficient way to train an image classification model and use it inside our mobile applications because it is provided by Google. So here when you are going to scroll down, you will be able to see the code. But instead of looking at this code here, what we need to do is to click on this Run in Google Colab button. And when we are gonna do that, this code will be opened inside Google Colab. And Google Colab is a tool for running Python code on browser without installing anything inside your system. So if you want to perform machine learning related operations or run the Python code for some purpose, then you can simply do it inside this Google Colab and you don't need to install any software inside your computer because it will gonna run on cloud servers provided by Google and it will gonna process things much more quickly as compared to your PC. So there you can see when I clicked on it, this Google Colab is opened and inside it we got this notebook model maker image classification tutorial. And here we will find the instructions to train our custom image classification model. And now here you need to make sure one thing, and that is you must attach the same Google account which you have used to upload the dataset. Like here you can see I uploaded this dataset inside my Google Drive and there I am using this Google account. And I have opened this Google Colab using the same Google account. So just like Google Drive, this Google Colab also requires you to attach your Google account with it. And you must attach the same Google account that you have used with your Google Drive. Otherwise, you will not be able to access the dataset and train the model. So now here you can see we got this notebook and we can simply run this code present inside it and train the model. So by default it contains the code to train a flower recognition application. So when you are gonna scroll down, you can see it is using this flower photos and then it will gonna train the model on those photos. But in our case, we want to train the model on our custom fruits dataset. So we need to make some changes inside this application and then we will be able to train the model to recognize those fruits. So scroll to the top of this notebook and now here you can read the instructions. So firstly we got this section prerequisites. So to run this example, we firstly need to install several required packages and by running this cell, these packages will be installed. So just click on the run button and this cell will be executed and all the required libraries will be installed inside this Google Colab. And when you are going to click on this run button for the first time, it will gonna take some time because it is assigning us a session and then we will be able to run the code. As there you can see the processing of this cell is started and it will be finished in a moment. So there you can see the execution of this cell is completed in 1 minute. And after that the next instruction is import the required packages. As for now we have installed the libraries and the next step is importing the packages from the libraries that we just installed. And this cell is containing those libraries. So firstly you can see it is importing this numpy library as np. Similarly, it is importing this TensorFlow library, which is the essential part for our model training process. So it is importing it, and then it is importing some libraries related to model maker. So we will not go into the details of these libraries, and we will simply run this cell. So just click on this run button, and this cell will be executed and our packages will be imported. And there you can see in 5 seconds the execution of this cell is completed as well. And now when you are gonna scroll down, you can see this section, get the data path. So here by default, this notebook is using the fruits dataset present on this link. But in our case, our dataset is uploaded on Google Drive, and we want to use it inside this Google Colab to train our image classification model. And to do that, we need to add some code inside this Google Colab. And we are gonna do that by just simply adding a code cell. So when you are gonna move your cursor at the top of this cell, you will see this option, add a code cell or a text cell. So if we want to write a Python code, then we need to import or add this code cell. So just click on it, and you can see a new cell is created here. And in this cell, we are going to write the code. As our dataset is present on Google Drive, so we need to attach our Google Drive with this Colab. And to do that, we are gonna write the code. So from google.colab, we are gonna import drive. So import drive. And after writing this line, add a new line character, and now we are gonna mount our Google Drive. And by mounting, it means that attaching this Google Colab with our Google Drive, and then we will be able to get the dataset from our Google Drive. So just call this drive.mount function. So drive.mount, and inside it we need to pass this text, content/drive. And that's it. So after typing these two lines, you need to run this cell, and then it will gonna ask you to attach your Google Drive. So just click on this connect to Google Drive button, and now you need to select the same Google account where you uploaded your dataset. So I'm gonna choose it, and then click allow. And there you can see this Google Drive is mounted, and this cell is executed successfully in 31 seconds. So after attaching our Google Drive, now we can access the dataset which is present inside this fruits dataset folder. And to do that, open the code again, and here you can see in this cell we are basically getting the path of our dataset, and we are storing it inside this image path variable. And later this image path is being used to access the dataset here. So we need to remove the code present in this cell. So just select it from here and remove it till this point. And now we are going to assign the path of our dataset to this image path variable. As in our case, our dataset is present inside this my drive fruits dataset folder, so we need to provide the complete path here. And this path will gonna start from this content/drive. So add the quotation, then write /content/drive, then add a /, and now specify the my drive folder. And inside it we created our fruits dataset folder, so just specify it as well. So fruits dataset, and that's it. So that is the complete path where we have uploaded our dataset. And in your case, if you named this folder something else, then you need to specify the same name here. So after doing that, just run this cell, and now this path is stored inside this image path variable. So now after importing the libraries and connecting the Google Colab, the next step is training our model, and then testing it, and then finally converting it into a TF-Lite format. So this notebook is designed in such a manner that firstly we got the model training process in simple 3 or 4 steps, and after that we got the whole process of training the model in further details. So here you can see we got this cell run the example, and here we just got the 4 cells, and in those 4 cells we got the code to train the model, test it, and convert it into a TF-Lite format. So you can see this step 1, which is about loading the model. Then this step 2 is about training the model. And this step 3 is testing the trained model. And the fourth step is converting the model into a TF-Lite format and downloading it. And below that we got the detailed process to train our image classification model. So here we got the same code, but we got more details and some more options. So we are also going to explore this part of our notebook, but for now let's go to the top and train our image classification model using these 4 steps. So scroll up and start the process. And you will see this cell, load input data specific to an on device ML app. So now we got this code to load our dataset. So there you can see data loader.from folder function. So it will gonna load all the dataset present inside this folder. And we are pointing it to this folder fruits dataset. So all the dataset present inside it will be loaded inside our Google Colab. And then it is doing one more thing, and that is splitting this dataset into training and testing. So there you can see this data.split. So this will gonna divide our dataset, and it will gonna keep 90% for training the model and 10% for testing the model. And it means that if we got 100 images for Apple, then 90 will be used while training the model and 10 images will be used for testing the model. So now let's run this cell, and then you will be able to see the dataset inside this Google Colab. So there you can see this cell is executed successfully. And after that you need to click on this file icon. And now here you can see this drive folder. So inside this drive folder you can see this my drive, and inside it you will be able to see this fruits dataset folder. And inside it we got our all 4 folders where we pasted the images. So now our dataset is loaded, and the next step is training our model. And to do that we need to just run this cell. So here you can see this image classifier.create function, and we are passing our training data. And when this line will be executed, our model training will gonna start. And by default it will gonna use our EfficientNet model and retrain it on our fruits dataset. And when the execution of this cell will gonna complete, we will get our trained model. So for now let's run this cell and see whether our model training starts or not. And there you can see we can see some details, and here the training stuff is started. So you can see the structure of the model you are using, and after that you can see the progress related to model training. So basically you can see there are 5 epochs. An epoch means that how many times our dataset will be passed to the model during training. So by default this epoch is 5, which means that during training 5 times our input images will be passed to our model and the model will be trained. And there you can see the execution of first epoch is just completed, and similarly the execution of second epoch is started. And here you can see different parameters for each epoch. Like the accuracy for the first epoch is 54% or 0.54, and it will gonna improve for the next epochs. And there you can see for the second epoch the accuracy of our model is 0.94, which means that 94% accuracy. So the accuracy is increased. Similarly, let's wait for the other 3 epochs, and then our model will be trained. And now you can see the execution of this cell is completed, which means that our model training is also completed. and there you can see the accuracy for the final epoch, and it is 0.98, which is 98%. But that is the accuracy for our training data. So when this cell is executed, our model is trained. Welcome to this lecture. As previously, we have trained our custom fruits recognition model and we downloaded it in a TF Lite format. And now it's time to change the model and retrain some other model. As by default, this create function is using the EfficientNet model and retraining it on our fruits dataset. But what if we want to train our model using the existing MobileNet model? So in order to do that, we just need to change one thing, and that is the parameter of this create function. So in this Google Colab, when you are going to scroll down, you will be able to see a section where you have the instructions to change the model. So here I am scrolling it quite down, and now you can see this section change the model, and there you will find the instruction to use some other model. So there you can see this library supports EfficientNet Lite model, MobileNet V2 model and ResNet 50, and by default EfficientNet Lite model is being used. So in order to change the model type, what we can do is to specify a parameter inside this create function, and that parameter is this model specs, and here you are going to specify the model name you want to use. So now we need to copy this code, so just copy this text and scroll above. And there you can see the cell which we used earlier to train our model. So this image classifier.create function, and inside it we need to paste the code that we just copied, and here add a comma before this model specs, and that's it. So now when this cell will be executed, our model will be trained again, but this time it will going to use our MobileNet V2 model. As previously it is using the EfficientNet Lite 0 model, but this time this MobileNet V2 model will be used, and we will be able to see the results using this model. So let's click on this run button again and train the model, and then we are going to compare the performance of this MobileNet V2 model with the EfficientNet model. So let's wait for our model downloading to be completed. So now the execution of this cell is completed and our model is trained again. So you can see the accuracy score for training, and the final accuracy score is 99%, but that is for training data, and the actual accuracy of our model is what we are getting for our test data. So just test this model by running this cell model.evaluate, and it will gonna pass our test data to this model, and we are gonna get the testing accuracy. And you can see the accuracy for EfficientNet model here, and it is 91%. And now let's see whether we are getting the better accuracy for MobileNet or not. So I am going to run this cell again. And there you can see this cell is executed again, and we got the accuracy score which is 97%. So it means that for our fruits recognition dataset, our MobileNet model is performing much more well as compared to our EfficientNet Lite 0 model. And we are getting 97% accuracy score on our testing data. Similarly, let's test this model by plotting the images as we did earlier. So just run this cell which is starting from this getLabelColor function, and it will gonna plot the results here, and we will be able to analyze the performance of our model much more effectively. And there you can see we again got the results, and this time there is only one wrong prediction. And now our model is detecting this picture correctly along with this picture. as previously both of these pictures were not predicted correctly, but now we got the correct prediction here, so kiwi here and apple here, and the only wrong prediction is for this picture. And similarly you can see the results for other testing images as well. So now our model is trained much more accurately. So let's also convert this model and download it in a TF-Lite format. And later we are going to use it inside our Flutter application and analyze the performance as well. So I am going to run this code which is present inside this block. So this model.export. So let's run this code. So now this cell is executed as well, and we again got this model.tflite file, and this time its size is 2.65 MB and it is trained on our MobileNet V2 model. So let's download it as well so that later we can use it inside our Flutter application. So now this model is downloaded as well. So till this point we have trained our image classification model on fruits dataset using two different models. Firstly we retrained our EfficientNet Lite 0 model, and now we retrained this MobileNet V2 model, and we got both of the models in a TF-Lite format here, and later we are going to use them inside our Flutter applications and perform image classification and object detection. Welcome to this lecture. In this lecture, we are going to use a ResNet 50 model and retrain it on our fruits dataset. As earlier, we have used two different models, this MobileNet V2 and EfficientNet Lite 0 model, and then we trained them on our fruits dataset. But this time we are going to use the ResNet 50 model. So inside this model specs.get function, we need to specify the name of our ResNet model. So type ResNet underscore 50, and that's it. Now when you are going to run this cell, our model will be trained and this ResNet 50 model will be used as a base model. And to this model our fruits dataset will be passed and it will be retrained on our fruits dataset. So now let's run this cell and then our fruits classification model will be trained. So let's wait for the model downloading to be completed. So now the execution of this cell is completed, which means that this ResNet model is retrained on our fruits dataset. And you can see our model training accuracy, and it is 99.6%, which is quite accurate. But the actual performance we will get by running the model or testing it on our test dataset. So let's run this third cell and our model will be tested. So now the execution of this cell is completed as well, and the testing accuracy is 94.4%, which is quite good. So it is in between for our EfficientNet model and our MobileNet model. As for MobileNet, our testing accuracy was 97%, and for EfficientNet Lite 0 model, it was 91%, and now we got 94%. Similarly, we can test this model or see the predictions returned by the model by running this cell again. So just run this cell and you will be able to see the predictions here along with the pictures. And there you can see the results. So this time we got only two predictions wrong and all the remainings are quite right. So there you can see for this image and for this image our prediction is not correct, and for remaining one the predictions are quite accurate. And now let's also convert this model and download it in a TF-Lite format so that we can use it inside our Flutter application. So I am going to run this fourth cell model.export and our model will be converted. So now the execution of this cell is completed and you can see this model.tflite file and its size is 23 MB. So this ResNet model is quite heavy as compared to MobileNet and EfficientNet model. So let's download the model as well so that we can use it inside our Flutter application. So now this model is downloaded as well. So till this point, we have trained our image classification model using three different models as our base model. Firstly, we retrained our EfficientNet model, and then we retrained the MobileNet model. And this time we have used this ResNet model and retrained it. So now we got three different versions of our fruit recognition model. And the next step is using it inside Flutter and performing image classification and object detection with both images and the live camera footage. And we are going to do that inside our upcoming lectures. Similarly, I have trained the model again, but this time using this EfficientNet Lite 4 model. And this is the heaviest and most accurate version of EfficientNet model family. So there you can see I already trained it, and our training accuracy is 0.98, which means that 98%. Similarly, I tested it on my testing dataset and the accuracy is more than 97%, and that is accurate as compared to Lite 3 and Lite 0. And after that I exported it into a TF-Lite format, and you can see this model.tflite file, and the size of model is 12.74 MB. So by looking at these things, you can also infer that the Lite 4 model is the most accurate one and its size is greater as compared to Lite 3, 2, 1 and 0. So we are also going to download it so that later we can use it inside our Flutter applications. Welcome to this lecture. As previously we have explored this notebook and we have trained our fruit recognition model. But as I told you earlier, there is also some code related to training the model, and that is the detailed process for training our model. So now we are gonna look at it. So when you are going to scroll down, you can see the sections where we are training the model, but now with some more detail. So firstly we got this cell where we are loading the dataset or getting the path of it. As above, we already attached our Google Drive with this Colab, and we got the path of our dataset folder. So we don't need to run this cell here in this detail process. So just skip this cell, and after that you have this cell where you are loading the dataset. So now we can simply run this cell and our dataset will be loaded. And after that we got the cell to divide our dataset into testing and training. But this time we are also getting the validation dataset as well. As above, we are just converting or dividing our dataset into two parts, 90% for training and 10% for testing. But this time we are dividing into three parts. We are keeping 80% for training, and then we are storing 20% inside this rest data variable, and after that we are dividing it equally, which means that we are keeping 10% for validation and 10% for testing. So this validation data is actually used to measure the model performance during its training, as this testing data is used to evaluate the model performance after training, but during training this validation data will be used. So now we have divided our dataset into three parts, so just run this cell. And after that we got a cell where we have the code to plot the images present inside our dataset. So it will gonna show 25 images from our dataset. So let's run this cell and you will be able to see the images here. And there you can see some of the images present inside our dataset. So after looking at these images, scroll down, and now here we got the code to train our model. But this time inside this create function, we are passing the training data along with the validation data. So this validation data is a new thing. And by default the EfficientNet Lite 0 model will be used as we have learned earlier. So let's run this cell and our model training will gonna start. And there you can see the training of our model is just started. So now let's wait for this training to be completed. So now the execution of this cell is completed, which means that our model is trained. And now you can notice some more information is here as compared to previously. As above, we are just getting the accuracy here while training the model. But this time we are also getting the validation accuracy and validation loss. So you can see the accuracy on the validation data during training the model. So when the first epoch will gonna complete, then our model will be tested on our validation dataset, and we are getting the score which is 68%. And after the second epoch, our validation accuracy was 97%, and it is maintaining it till the fifth epoch. So by using the validation data, we can also test the model performance during the training itself. So that's the advantage of this data. So now we have trained our model. The next step is running this cell, and we will be able to see the structure of our model. So let's run this cell. And now here you can see the structure. So basically you will be able to see the number of parameters or variables present inside our model. So there are basically more than 34 lakhs parameters present in the model, and the trainable parameters are 5124. So our whole model will not be trained, but only some layers at the end of our model will be retrained on our custom dataset. And apart from that, the power of existing model will be used. And similarly, you can see the output here. So there you can see this 4 here, and it is indicating the number of classes which our model can recognize. As we are training it on just 4 fruits, so we are getting 4 here. Similarly, if you are training it on some more items, then you will get this number increased here. So after looking at the model structure, scroll down, and now you can again evaluate the model by running this cell. So here we are going to get the model accuracy score on our testing data in a moment. And there you can see our model accuracy is 97.22%. So our model is quite accurate. And after testing it, we can again plot the results and see the predictions along with the images. So let's run this cell, and it will gonna take 100 images from test dataset and plot them. As in our case, there are not 100 images inside our testing dataset, so it will gonna take whatever the images present inside it. And here we are going to see the images along with the predictions. And now here you will be able to see the picture and the prediction. And this time we only got one prediction wrong, which is for that image. Apart from that, all the predictions are quite accurate. So our model is performing quite well. Similarly, we can use the other model like EfficientNet Lite 3, 2, 1 or 4 and test the model performance. So after looking at these results, the next step is again exporting the model or converting it into a TF-Lite format. And we can do that by running this cell. So I executed this cell, and in a moment our model will be converted and we will be able to see it here inside this pane. So now this cell is executed and our model is converted. And here you can see this model.tflite file, and its size is approximately 4 MB. And this is our trained model. And we can simply download it by clicking on this download button. Similarly, when you are going to scroll down, you are going to see some options for this export function. Like if you want to download the label file or the file with the name of detected classes, then you can run this command. So here basically you are specifying the export format to label, and it will gonna generate our label file. So let's run this cell. And now in this pane you will be able to see this labels.txt, and when you are going to download it and open it, you will be able to see the name of the classes which your model can recognize. And in our case these are apple, kiwi, pineapple and watermelon. But all this information is also associated with this model.tflite file because this model has a metadata associated with it. Similarly, we can also test our TF-Lite model, and we can do that with the help of this model.evaluate TF-Lite function. And our testing data will be passed to this TF-Lite model and we will get the results. So let's run this cell. So now the execution of this cell is completed and we are getting the accuracy score 97.2% for our converted model. As above, we have tested our model, but that model was not converted, and we tested it on our testing dataset. But this time we are testing our model.tflite file, and its accuracy score is equally good. So now we have also tested this model.tflite file before using it inside our Flutter application. So you can verify the performance of your converted model as well. So now we have explored this notebook further and we are able to perform some more tasks as compared to the previous version, as we covered this detailed process, and now we are able to divide our dataset into three parts. So apart from training and testing, we are getting our validation data here, and then we are passing it during our training the model, and we are getting the validation accuracy score, and by using it we are able to analyze the model performance during training. Similarly, we looked at the model structure, and after that we evaluated our model, and then we have looked at the images where we are getting the prediction along with the image itself, and finally we are able to export the model along with the label file. And then the main thing is testing the TF-Lite model. So we are also able to achieve that in this detailed process. So we are testing our model file which is in a TF-Lite format, and we are getting the accuracy score for it. So you can verify your model accuracy score before using it inside your Flutter application. So this is another important step in the whole process. So hopefully you got the idea that how you can train your custom image classification model and use different families of models and retrain them. Hello and welcome to this lecture. In this lecture, we will start using the model that we trained earlier inside our Flutter application. So firstly, we are going to use that model in Flutter and perform image classification with images. And later we are going to use it with the live camera footage to build a real-time image classification application. So let's begin. So the first step is getting our application code from GitHub. And this is the application code that we completed earlier when we learned to integrate pre-trained image classification model in Flutter. So if you have completed that section, then you can take that application code and open it, and you can integrate the model that we trained by just yourself. Otherwise, follow me on this lecture. So open your browser and go to this link. And once this repository page is open, just click on the code button and copy this repository link. Then open your Android Studio and here click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now our application is cloned successfully. So let's firstly install this application inside an emulator and verify the working of this application. And this is the application in which we are using the EfficientNet model and this MobileNet model for performing image classification with images. And we have completed this application inside our previous section where we learned to integrate pre-trained image classification model in Flutter. So if you did not complete that section, then you must do it. Otherwise, you will not be able to understand that how we integrated these TF-Lite models inside Flutter. So let's install this application inside an emulator and verify the working of this application. So now the application is installed inside the simulator, and that's the GUI of this application. So here user can choose an image from gallery by clicking on this camera icon, and he can capture an image by long pressing on this camera icon. So let's choose an image from gallery. So we are going to choose this ostrich image. And now you can see this image is being displayed here, and below that we got the prediction, which is ostrich, and the confidence score is 99%, which means that our model is working quite accurately. And in this application we are using this MobileNet.tf lite model to perform this image classification. So when you are going to open our lib folder, inside it we got this main dot dot, and inside it you will be able to see that we are specifying the name of this MobileNet model here. Similarly, if you want to use EfficientNet model, then you can specify the name efficient here. So that is our current application. And now we want to use the fruits recognition model that we trained earlier inside this application. And we are going to do that inside our next lecture. Welcome to this lecture. As previously, we have imported our application code and you have seen the working of this application. And now it's time to use our fruits recognition model inside this application and perform image classification using that model. So the first step is you need to open the folder where you got your trained model. Like here I got these three trained model. This fruits EfficientNet, so that is the model we trained when we are using the EfficientNet model as our base model. After that we got this fruits MobileNet, so it is retrained on our MobileNet model. And finally we got this fruits ResNet, and we have also learned to train it during our model training section. So after getting these three model files, you just need to copy them and paste them inside this ML folder. So I'm gonna paste it here. So click OK. And now you can see these three models file here. So firstly we are going to use this EfficientNet model and test its performance inside this application. After that we are going to try this MobileNet model and ResNet model. So let's begin by specifying the name of our fruits EfficientNet model here. So scroll up and inside this create labeler function, we need to specify the name of our fruits EfficientNet model. And that's it. So be careful with the spellings, because if you did not specify them correctly, then our model will not be loaded. So after specifying the name, we just need to run this application again, and after that we are going to test this model with images. So firstly stop this main dot dot and run the application again inside the simulator. So now our application is installed again, so let's choose an image from gallery and test this application. So we are going to start by choosing a watermelon image. So I am going to select this one. And there you can see we got a prediction watermelon and the confidence score is 92%, which means that this prediction is quite right and our fruits EfficientNet model is working correctly. Similarly, let's choose a kiwi image like this one. And you can see we are getting the prediction kiwi with the confidence score of 0.99. So our application is working correctly and it is recognizing kiwi quite well. So now let's test it for pineapple. So I'm going to use this image. And there you can see it is also recognizing it correctly with the confidence score of 0.98. And finally we are going to try these apples. And there you can see it is also being recognized with the confidence score of 0.93 or 93%. So our application is working correctly and this fruits EfficientNet model is returning some quite accurate results. Similarly, you can install this application inside your real device and test it by using both images from gallery or capture the images using your device camera and test the performance of this model. Welcome to this lecture. As previously, we have integrated our fruits recognition model inside this Flutter application and we have performed recognition on images. And now it's time to try this MobileNet and ResNet model. So firstly, we are going to try this MobileNet model, so just specify the name of model here. So fruits MobileNet. And that's it. So after specifying this name, let's install the application again and test the working of our application. So now our application is installed again. So let's test the working of this MobileNet model by choosing the images from gallery. So we are gonna use the same images that we use for EfficientNet model so that we can compare the performance of model. So let's choose this image. And there you can see we got the prediction watermelon with the confidence score of 0.89%. So it is being recognized correctly. Similarly, let's try kiwi. So there you can see the confidence score is again 99% and the prediction is also right. Similarly, we are going to try for this pineapple. And there you can see it is also recognizing this pineapple pieces quite well and we got the correct prediction. And finally for apples, so let's try these ones. And you can see we got 99% confidence score for this apple prediction. So our application is working correctly and this time we are using this MobileNet model. So after using both EfficientNet and MobileNet model and performing image classification, let's use this ResNet model and see the results. So I am going to change the name here. So fruits ResNet. And after that, let's restart our application so that we can test the working of it. And there you can see our application is restarted. So let's choose an image from gallery. So we are going to choose this image. So there you can see we got a prediction watermelon with the confidence score of 0.84%. So this confidence score is little bit low as compared to our MobileNet and EfficientNet model, and you have noticed that our application took some time to return this prediction. And the reason is this ResNet model is quite heavy as compared to MobileNet and EfficientNet model. So it will going to return the results by taking some time. Similarly, let's test it for other images like for this kiwi image. So there you can see we got the prediction kiwi with the confidence score of 86%. So let's try it for pineapple. So there you can see for this pineapple our confidence score is quite good. So we got the prediction pineapple and our confidence score is 99%. And finally let's try this apple. So there you can see we got the correct prediction and the confidence score is 99%. So our ResNet model is also working quite well and it is recognizing the results. Similarly, if you have retrained the EfficientNet Lite 3 or Lite 4 models, you can also use them inside this application by just adding them inside this ML folder and then changing the name here. And now let's quickly review the process that how you can use your own trained image classification model in Flutter. So if you are following this course and you have trained your model, what you need to do is to download this application code from GitHub. And if you have completed the previous section where we learned to integrate pre-trained image classification models in Flutter, then you have already got this code. So after getting this code, what you need to do is to paste your model inside this ML folder and change the model name here. And that's it. You don't need to change anything inside this application code. You can simply run this application inside your device and test the working of this application and analyze the performance of your model. So now I have installed the application inside my real device, and inside this application we are using our own trained fruits recognition model. And there you can see when I am pointing it at the picture of watermelon, it is detecting it quite well with the confidence score more than 95%. Similarly, let's test it for pineapple. So there you can see we are again getting the correct prediction with more than 95% confidence score. Similarly, let's test it for apple. And there you can see this apple is also being detected. Similarly, let's try it for kiwi. And there you can see it is also detecting it for this kiwi quite well. So our application is working correctly and we are getting the results using our fruits recognition model and we are testing it with the live camera footage. So now we have tested the application and it is working quite well. Similarly, you can use the other models like this Fruits MobileNet model or this fruits ResNet model by just changing the name here. So in order to test this MobileNet model, just type fruits MobileNet here and install the application again inside your real device, and you will be able to test the performance of this MobileNet model. And same is the case with this ResNet model. But we are not going to test both of these models, and it is up to you to test them by yourself. So just specify their name here and test the application. Similarly, if you got some other model, like you got an image classification model which got a metadata associated with it, you can simply paste it inside this ML folder and then change the model name here. And after that, you can test the performance of that model inside Flutter. Hello and welcome to this lecture. In this lecture, we are going to use the fruits recognition model that we trained earlier, and we are going to perform object detection using that model. So as earlier, we have learned that how we can use image classification models in Flutter and perform object detection using those image classification models. So basically we are going to detect the objects using the object detection API of our ML Kit library, and then we are going to recognize those detected objects using our image classification models. And now we are going to use the image classification model that we have trained earlier to recognize the detected fruits. So let's begin. So the first step is getting this application code from GitHub. And if you have completed the previous section where we learned to use pre-trained image classification models in Flutter for performing object detection, then you can open that application code. Otherwise, you can take the application code from GitHub. So open your browser and type this URL. And once this repository is opened, click on the code button and copy this link. Then open your Android Studio and here click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the application code is imported, and this is the same application that we completed inside our pre-trained object detection section of this course. So if you have completed that section, then you can integrate our fruits recognition model inside this application by yourself. Otherwise, you can follow me on this lecture. So here you can see inside our assets folder, we got our EfficientNet.tflite and this MobileNet.tflite model. So inside this application, we are using these models to recognize the detected objects. So what we can do is to install the application inside our emulator and verify the working of this application. After that, we are going to use our fruits recognition model inside this application to recognize detected fruits. So I am going to install this application inside an emulator. So now the application is installed inside the simulator, and here user can choose an image from gallery by clicking on this camera icon. Similarly, he can launch the camera and capture the picture by long pressing on this camera icon. So let's choose an image from gallery and verify the working of this application. So I am going to choose this ostrich image. And there you can see a rectangle is being drawn around this ostrich, and we got the label ostrich here. So our application is working correctly, and we are using this MobileNet model to recognize this detected object. So the object detection model of our ML Kit library is detecting the location of this ostrich, and after that, in order to recognize it, we are using this MobileNet model. So this application is working correctly. Welcome to this lecture. As previously, we have imported our application code and we have verified the working of this application. And now it's time to use our fruits recognition model to recognize detected fruits. And to do that, we need to open the folder where we got our trained model. Like here I got this fruits EfficientNet model, this fruits MobileNet and fruits ResNet model. And these are the models we trained inside our model training section. So I downloaded them and I renamed them. And now it's time to use them inside Flutter for performing object detection. So just copy these models and we need to paste them inside our ML folder. So just paste them here and click OK. So now our models are added in this ML folder, and for some reason the ResNet model is not copied. But you can see this fruits EfficientNet and this fruits MobileNet here. So these are the models we trained earlier. And now it's time to use them inside this Flutter application for performing object detection. So open our main dot, and here you will find this method create object detector, and we are specifying the name of our MobileNet model here. So previously the MobileNet model is recognizing this ostrich, but as we want to use our fruits model, so we just need to change the model name here. And after that we can run the application and test the model whose name we typed here. So firstly we are going to use this fruits EfficientNet model. So just specify the name here. So fruits EfficientNet. And be very careful with the spellings, because if you put them wrong then you will not able to load the model and use it. So after specifying the model name, we are just going to click on this top main dot and we are going to click on this run button. So now the application is installed again, so let's test our model by choosing an image from gallery. So I am going to choose this apple image, and there you can see our apple is being detected and a rectangle is being drawn around it. And we also got the text apple here. So it means that this apple is being detected and recognized correctly. And we are detecting the location of this apple using object detection model of our ML Kit library. But we are recognizing it using this fruits EfficientNet model. Similarly, let's test our application for a different image, like for this pineapple. And there you can see we got a rectangle around it and we got the text pineapple here. Similarly, let's try it for kiwi. And there you can see we got the rectangle around both of these kiwis and we got the label kiwi here. And finally test it for watermelon. So I'm gonna choose this image. And there you can see the watermelon is being detected along with the two pieces. So we got the rectangle drawn around this piece. Similarly, we got one here and that one. So our application is working correctly and we are able to detect these watermelons along with the other objects quite well. So as previously, we have tested this fruits EfficientNet model inside our Flutter application with images. And now let's try this MobileNet model. So in order to use it, just change this fruits efficient to fruits MobileNet. So I'm gonna remove this EfficientNet and add MobileNet here. So MobileNet, and that's it. Now let's restart our application and test it. So there you can see our application is restarted. So let's choose the image again. So I am going to choose this apple image. And there you can see all three apples are being detected correctly and they are all being recognized as apple. So our application is working correctly and we are able to detect these apples. Similarly, let's try it for this pineapple. And there you can see we got the rectangle around this pineapple and this text pineapple here. And now try it for kiwi. So there you can see it is also being detected quite well. And finally for watermelon, so let's choose this one. And there you can see we got the rectangle around both of these watermelon. So we got the rectangle around this whole watermelon and this piece of watermelon. So our MobileNet model is working correctly and we are able to detect the fruits using this model. So basically the object is being detected with the help of our object detection model that ML Kit provides. And after detecting the objects, we are passing this detected object to our image classification model and it is assigning the label or recognizing it. So after testing this fruits EfficientNet and this MobileNet model, let's try this fruits ResNet model as well. So just change the model name here. So remove this MobileNet and add ResNet here. And now let's restart our application and our ResNet model will be loaded. And there you can see our application is restarted. So let's choose the image again. So I am going to choose this image. And there you can see we got the rectangles around all of these three objects, but we got one wrong prediction here, which is for this apple. So we got watermelon here. So our EfficientNet and MobileNet models are much more accurate as compared to this ResNet model. Similarly, let's try it for a different image, like for this pineapple. So there you can see we got a rectangle drawn around this pineapple and this label pineapple, so it is being recognized quite well. Similarly, let's try it for this kiwi. And there you can see we got the rectangle around both of the kiwis and we got the true label, which is kiwi. So it is working quite well, but we got a wrong prediction in case of apple. And finally, try it for the watermelon. So I'm gonna choose this image. So there you can see the watermelon is being detected and recognized quite well. So our ResNet model is also working quite well. And in case of this ResNet model, you may face a delay in the results. And the reason is this ResNet model is taking much more time to return the results. So that's why we are getting the rectangle drawn around these objects after taking some time. But in case of this EfficientNet model and MobileNet model, they are lighter as compared to the ResNet model. And their size is also like 3 or 4 MB, but this ResNet model is around 25 MBs. So now let's quickly review the process that how you can use your own trained image classification model in Flutter for recognizing detected objects, or in other words for performing object detection. So firstly you need to get the application code from GitHub. So you can take this application code by visiting this repository. And once you have imported the application code, you need to paste your model inside this ML folder and then specify your model name here. And that's it. After that, you can simply run the application and test the performance of this application with images. You don't need to change anything inside this application code, and that's the beauty of our ML Kit library, that it handles all the other operations by itself. But keep in mind that we are using the image classification models in the form of this TF-lite file. So object detection is being performed using the default object detection model of our ML Kit library. And then to recognize those detected objects, we are using these image classification models. So that's how we are achieving object detection with the help of our image classification models. Welcome to this lecture. As previously we have imported our application code from GitHub, and in this application we are performing object detection with the help of this MobileNet model. And now it's time to use our fruits recognition model. So open the folder where you got your models. Like here I got these three models, this fruits EfficientNet, fruits MobileNet and fruits ResNet. So these are the models we trained inside our model training section, and now we are going to use them in Flutter with the live camera footage. So just copy them and paste them inside this ML folder. So I'm gonna paste them here. Now click OK and you will be able to see these models here. So after adding the models, the next step is specifying the model name you want to use. Like I want to try this fruits EfficientNet model first, so I'm gonna specify its name here. So fruits. So be very careful with the spellings, because if you put them wrong then the model will not be loaded. So after specifying the name, we can just simply run the application inside our real device and test the working of this fruits EfficientNet model. And we don't need to change anything inside this application. And that's the beauty of our ML Kit library, that it handles all the other operations by itself. So let's install the application inside our real device and test the working of this fruits EfficientNet model. Welcome to this lecture. As previously we have used our fruits recognition model inside Flutter with images, and we are detecting fruits with the help of that model. And now it's time to use this model with the live camera footage. So we are going to build a real-time fruits recognition application. And if you have completed the previous section where we have learned to integrate image classification models in Flutter for performing object detection, then you can do it by yourself. you just need to open that application code and add the model there. And after that, you need to specify your model name, and that's it. And if you got any problem, then follow me on this lecture. So the first step is getting our application code from GitHub. So open your browser and type this URL. Or you can also take this URL from project resources. And once the repository page is open, just click on the code button and copy this repository link. Then open your Android Studio and click on this get from version control and paste the link here. Now click clone and our project will be cloned in a moment. So now our application code is imported. So this is the same application that we completed inside our previous section, where we have learned to use pre-trained image classification models in Flutter for performing object detection. So here you can see we got the assets folder, and inside it we got the EfficientNet model and this MobileNet model. So we have learned to use these models in Flutter for performing object detection. So basically we are detecting the objects using the object detection feature of ML Kit library. But in order to recognize those detected objects, we are using these image classification models. So this is the complete application code, and you can verify the working of this application by simply installing it inside your real device. And then you will be able to see that by using this MobileNet model, we are recognizing the detected objects. But now our goal is to use our fruits recognition model that we trained earlier. But before doing that, go to our pubspec.yaml file and click on this pubget so that all the libraries that we are using will be downloaded. And you will see that the errors will be gone. And there you can see the libraries are imported. After that, open this lib folder and go to this main dot. And here when you are going to scroll down, you will see this method initialize camera. And inside it you will see this MobileNet.tfLite. So for now we are using this MobileNet model and recognizing detected objects using it. But now it's time to use our fruits recognition model, and we are going to do that inside our next lecture. So see you in the next lecture. So now we have installed the application inside our real device, and in this application we are using our own trained fruits recognition model to recognize the detected fruits. And there you can see when I am pointing it at these kiwi pictures, the both of the kiwis are being detected quite well. So we got the rectangle around both of them and the label kiwi here. Similarly, let's scroll down and test it for further images. So you can see we are getting the prediction right in most cases. Similarly, let's test it for apples. So there you can see we got a rectangle drawn around this apple. Similarly, let's try it for these images. So there you can see it is detecting them quite well. Similarly, let's try it for pineapple. So there you can see we got a rectangle around this pineapple as well. Similarly, let's scroll down and you can see it is recognizing pineapple in most of the cases. Similarly, try it for watermelon. So there you can see the watermelon is being detected quite well. And when we are scrolling down, we are getting the correct prediction in most of the cases. And in some cases, we are getting some wrong predictions as well. But mostly it is detecting watermelons quite well. So our fruits model is working quite well. So now we have tested our application and it is working quite well. Similarly, you can try this fruits MobileNet model and this fruits ResNet model by just specifying their name here. And you don't need to change anything. Like if you are gonna type fruits MobileNet here, then you can simply run the application and this fruits MobileNet model will be used for recognizing the detected objects. And you can try the same for this fruits ResNet model. And same is the case for any other image classification model which have a metadata associated with it. You can simply put the model in this ML folder and then specify the name here, and you will be able to test the model in Flutter with the live camera footage.